Hey everyone, tonight we're stepping into one of the strangest and most quietly unsettling questions that science has ever dared to ask out loud. Not a question about aliens on some distant world, not a question about the future, a question about the ground beneath your feet, about the rock and the soil and the deep, dark layers of this planet, and about everything that came before us. Tonight, we're asking whether we are truly the first to build, the first to think, the first to look up at the stars and wonder, or whether, somewhere in the unimaginable depth of Earth's past, something else got here long before we did, lived, rose, and vanished so completely that we would never even know. Before we begin, take a moment to subscribe, but only if you genuinely enjoy what I do here. This is a small channel, and every single subscriber truly matters to me. And drop a comment telling me where in the world you're listening from and what time it is for you right now. I love reading them. Now dim the lights, get comfortable. Let your shoulders drop, let your breathing slow, and let's ease into tonight's journey together, gently, slowly, into the deepest of all deep waters, the ocean of time itself. There is a kind of question that feels different from other questions. Most questions, when you ask them, point outward, toward facts you can go and gather, toward answers waiting somewhere to be found. But a few rare questions point in a stranger direction. They point at the edges of what we can know at all. They make you aware, suddenly, of how much darkness surrounds the small lit circle of everything we understand. And the question we're sitting with tonight is one of those. It is simple to say, and almost impossible to answer, and once it's been said, it is very hard to unhear. The question is this: if, hundreds of millions of years ago, long before the first human being ever walked the earth, an intelligent species had risen on this same planet, built cities, lit fires, dug mines, changed the very air and the seas, and then for whatever reason disappeared, leaving the planet to recover and to forget, would we, today, with all our science and all our instruments, be able to tell that they had ever existed at all? Would there be anything left? Any trace, any whisper, any faint mark pressed into the rock that we could read and recognize as the work of a thinking mind? Or would the simple, patient erosion of time have wiped the slate so utterly clean that the entire story would be lost forever, leaving us to believe, perhaps wrongly, that we were the very first? It sounds at first like the opening line of a science fiction novel, and in a way the name it has been given does come from a story. But the question itself is not fiction. It was asked seriously and carefully by two respected scientists in a paper published in a peer-reviewed journal, and it has quietly haunted the people who study these things ever since. Because the honest, uncomfortable answer they arrived at was not a confident no. It was something far stranger. It was, essentially, we're not entirely sure. And tonight, slowly and gently, in the soft dark of this late hour, we're going to walk all the way down into that uncertainty together and explore what it means, and somehow by the end find in it not fear, but a strange and beautiful kind of peace. So settle in. There's no rush at all. We have all the time in the world. In fact, time is exactly what tonight is about. Far more of it than your mind was ever built to hold. The idea has a name, and the name itself tells a small story. It is called the Silurian Hypothesis. And if that word, Silurian, tugs at some half-forgotten corner of your memory, there's a reason for that. The Silurian is, first of all, a real and genuine period in the geological history of our planet, a long stretch of time more than 400 million years ago, when the land was only just beginning to be colonized by the earlier simple plants and the first small creatures venturing out of the ancient seas. But that is not actually where the name of the hypothesis comes from. The name comes a little playfully from elsewhere. It comes from an old episode of a long-running television show in which a fictional race of ancient intelligent reptiles who had supposedly ruled the Earth in the unfathomably distant past awaken from a long sleep to find that mammals, that we, have inherited their world. The scientists who proposed the hypothesis borrowed that name as a kind of gentle, knowing wink. A way of saying, we know how this sounds, we know it echoes old stories, but please, hear us out. Because the science underneath is real. The two people who gave us this idea were not fringe thinkers or sensationalists. They were exactly the opposite. One of them is a climate scientist named Gavin Schmidt, who at the time directed one of the most respected climate research institutions in the world, a NASA laboratory devoted to studying the Earth's atmosphere and the long, slow rhythms of its changing climate. The other is an astrophysicist named Adam Frank, a professor whose work focuses, among other things, on the search for life beyond our own planet, and on the question of how we might ever recognise a distant civilization if we found one. Two careful, credentialed scientists working at the very centre of mainstream research. And in the year 2018 they published a paper together in a journal devoted to astrobiology, the science of life in the universe, and they gave it a title that was really just a question. The question was whether it would even be possible to detect an industrial civilization in the geological record. Now here is the part that is so important to understand, the part that protects this whole idea from sliding into nonsense. Schmidt and Frank were not claiming that there had been a previous civilization on Earth. They were not announcing a discovery. They were not saying, we have found the ruins of the lizard people. Quite the opposite. They were perfectly clear, and they remained clear in every interview afterward, that they believed, as all the evidence still strongly suggests, that human beings are the first technological species ever to arise on this world. There is no good reason to think otherwise. The entire weight of geology and biology and archaeology points to us being first. So this was never about belief. It was about something subtler, and in a way far more profound. It was a thought experiment. A test, not of the past, but of our own ability to read the past. Think of it the way a detective might. Imagine arriving at a place where something may or may not have happened, long, long ago, only to find that rain has fallen on it every day for 50 million years. The footprints, if there were any, are gone. The fingerprints have dissolved. The room itself has been rebuilt 1,000 times over, torn down and raised again by forces that care nothing for evidence. A careful detective standing in such a place would not say with confidence that nothing ever happened here, nor would they invent a crime from thin air. They would say honestly that the scene has been so thoroughly washed and rebuilt that they could not be sure either way, and they would then ask a sharper question. Not what happened, but what kind of trace, if any, could possibly have survived this much rain, this much rebuilding? That is exactly the question Schmidt and Frank were asking. Not did a civilization exist, but if one had, what would be left to find, and would we even recognize it as evidence at all? The whole investigation is about the reliability of the witness, and the witness, in this case, is the Earth itself, which is a forgetful and unreliable witness indeed. When the paper appeared, it caused exactly the kind of stir you might expect. The headlines, of course, lean toward the sensational, conjuring images of ancient lizard empires and lost reptilian cities, which was never what the authors meant, and which they patiently corrected at every opportunity. But among scientists, the reaction was more thoughtful and more interesting. Many of them realised that the paper had quietly put its finger on a genuine blind spot, a gap in our confidence that we had simply never examined before. We had all assumed, without really checking, that of course we would know if someone had come before us. And here were two serious researchers demonstrating carefully and soberly that this assumption rested on far less solid ground than anyone had supposed. The value of the paper was never in its answer, because it offered no firm answer. The value was in the question, and in the way it forced an entire field to think more honestly about the difference between what is true and what is merely findable. That distinction between truth and detectability is one of the deepest ideas in all of science, and the Silurian Hypothesis is one of the clearest and most haunting illustrations of it ever devised. The real spark for the whole thing, the moment the question was born, is a lovely little story in itself. The astrophysicist Frank had come to visit the climate scientist Schmidt to talk about exoplanets, about distant worlds circling other stars, and about whether, if a civilization had risen and altered the climate of one of those faraway planets, we might one day be able to detect the fingerprints of that change from across the gulf of space. And as they were talking through how a civilization leaves marks on its own world's climate, Schmidt, the climate scientist, paused and asked a question that stopped the whole conversation cold. He asked, more or less, how do we know that this has only ever happened once here with us? How do we know we are the only time an industrial civilization has ever appeared on the Earth? Frank, by his own account, assumed at first that of course we would know, that surely we would have found something. And then the two of them actually sat down to work out whether that was true. And the more carefully they looked, the more they realised that the confident answer they'd both expected simply wasn't there. Because here is the thing they came to understand. When we say we are the first, what we usually mean is that we have never found evidence of anyone before us. But absence of evidence, as the old saying goes, is not the same as evidence of absence. The question they were really probing was not whether the evidence is there. It is whether the evidence could be there, whether the planet itself is even capable of keeping that kind of record over such enormous spans of time, and that turns out to be a genuinely hard scientific problem. Because civilizations, even great ones, even ones that reshape a planet, are astonishingly brief, and the Earth is astonishingly old. And the gap between these two scales, the flicker of a civilization against the slow turning of geological time, is so vast that it changes everything about what we can hope to know. Think about it this way. Our own industrial civilization, the one that burns fuel and builds cities and sends signals into space, is only a few hundred years old. A few hundred years. Set that beside the age of the Earth, which is measured not in hundreds of years, not in thousands, not even in millions, but in billions. 4.5 billion years. The entire span of human civilization, every empire, every cathedral, every road, every book, every war, every song, is a thin film of time floating on the surface of an ocean so deep that we cannot see the bottom. And if our entire industrial age might one day compress in the rock record into a layer thinner than a sheet of paper, then how much would we really expect to find of someone whose age came and went 100 million years ago? Maybe a great deal, or maybe nothing at all. That uncertainty, that genuine, unsettling, scientifically honest uncertainty, is the whole heart of the Silurian Hypothesis, and over the next 2 hours we are going to follow it down, layer by layer, into the deep. To even begin to take this question seriously, we first have to do something that the human mind is famously bad at. We have to feel, not just know, but actually feel how old the Earth really is. And this is harder than it sounds, because our minds were never built for it. We evolved to track the passing of days and seasons, to remember the lives of our parents and grandparents, to think ahead, perhaps, to our children and theirs. A human lifetime is the natural unit of our imagination. A century already strains it. 1,000 years is, for most of us, an abstraction, a number more than a feeling. And yet 1,000 years is nothing, less than nothing, against the timescales we're about to wade into tonight. So before we go any further, let us slow down and try, gently, to stretch the mind wide enough to hold the truth. The Earth is about 4.5 billion years old. 4.54 billion years, to be a little more precise. Let that number sit in the quiet for a moment. 1 billion is 1,000 million. So the Earth has existed for roughly 4,500 million years. If you tried to count to 4.5 billion, one number every second, never sleeping, never stopping, it would take you well over 100 years. You would die long before you reach the end. And that is just to count the years, one by one. Each of those years held 365 sunrises, each sunrise its own slow unfolding of light across an ancient sky that no one was there to see. Scientists have a name for this overwhelming expanse. They call it deep time. The phrase was born in the study of geology, when people first began to realize, with a kind of vertigo, that the layers of rock beneath them recorded a history far longer than anyone had ever imagined. A history measured not in the few thousand years of human record, but in unthinkable depths. One early geologist, gazing at the layered cliffs that revealed this truth, wrote that the mind seemed to grow giddy looking so far into the abyss of time. Giddy. That dizziness, that vertigo, is the correct and honest response. It is the feeling of standing at the edge of something genuinely too large for us. And tonight, instead of pulling back from that edge, we are going to lean into it, slowly, and let it carry us toward rest. Let me try to give that abyss a shape you can hold. Imagine, if you will, that the entire history of the Earth, all 4.5 billion years of it, were compressed into a single calendar year. The planet forms in the first cold seconds of the 1st of January. For the longest time, almost the whole year, nothing lives at all, or only the simplest specks of life, single cells drifting in ancient seas, doing nothing but existing, dividing, persisting for month after month after month of our imaginary year. The first simple life appears perhaps in late February or March, and then, for an astonishing stretch, the world remains a place of microbes alone. Not until the autumn of this compressed year, around the middle of November, do the first complex animals begin to appear. The great ages of fish, of the first creatures crawling onto land, of vast forests and giant insects, all of it crowds into the final weeks of December. The dinosaurs, those rulers of 165 million years, arrive in the 3rd week of December and are gone by the day after Christmas, wiped away in an instant of cosmic violence. The age of mammals, the rise of the great beasts, the slow shaping of the world we would recognise, all of that happens in the last 5 days of the year. And human beings, our own kind, recognisably modern human beings, do not appear until the very last hour of the very last day. The 31st of December, late in the evening, and all of human history, every civilization that has ever existed, the pyramids, the empires of Rome and China and the Americas, every word ever written, every life you have ever heard of, all of it fits into the final few seconds before midnight. The whole of recorded history is the last breath of the dying year. And our industrial age, the thing the Silurian Hypothesis asks about, the burning of fuel, the building of the modern world, that is the final fraction of the final second, less than the blink of an eye before the clock strikes 12. There's another way people sometimes try to feel this, and it is even simpler. Stretch out your arms as wide as they will go, and imagine that the whole history of the Earth runs from the tip of the fingers on your left hand to the tip of the fingers on your right. Across that entire span, your left fingertips the molten birth of the planet, your right fingertips the present moment. Almost the whole of it is lifeless, or home only to the simplest microbes. Complex animals do not appear until somewhere around your right wrist. The dinosaurs come and go within the palm of your right hand, and all of human history, every empire and every name you have ever learned, could be wiped away in a single gentle pass of a file across the very tip of your right middle fingernail. One light stroke, and we are gone. That is how much of this story we are. A nail's edge at the very end of an outstretched arm. And here is something worth resting on, because it is so easy to skip past. For the overwhelming majority of the Earth's existence, for billions of years, nothing happened that we would call eventful at all. No dinosaurs, no forests, no fish, no insects, no flowers, just water and stone and sky, and in the seas the slow, silent, endless work of single cells, dividing and drifting and dying, age upon age upon age, with no eyes anywhere to see it and no minds anywhere to mark the passing of the years. Imagine the patience of that. Imagine a world that turned through more than 2 billion years of dawns and dusks with nothing more ambitious upon it than a film of green slime on the rocks at the edge of an ancient sea. We tend to think of life as a story of constant progress and drama, but for most of its history, life simply persisted, quietly, gloriously, doing almost nothing, for spans of time so vast they make the entire age of the dinosaurs look brief. The deep past is not mostly excitement. It is mostly a long, slow, unbroken quiet, and there is something profoundly restful in that thought here in the late hours as the world outside your window grows still. Now hold that picture in your mind, because it is the key to everything. In that compressed year, where would a civilization that rose and fell 100 million years ago appear? It would fall somewhere in the middle of December, deep in the age of the dinosaurs. And how long would it last? If it endured even as long as our entire human story, it would be a flicker of a few seconds, somewhere in those crowded final weeks. A few seconds in a place we have almost no way of looking back to. The point is not that such a thing happened. The point is how easy it would be, on a calendar this crowded and this vast, for a few seconds in mid-December, to leave no mark that survived all the way to the final stroke of midnight. The Earth's history is divided by the people who study it into great chapters, and the names alone have a kind of music to them when you say them slowly. The oldest and most mysterious is called the Hadean, name for the underworld, an era of a molten, hellish young planet still cooling from its violent birth, bombarded by debris, with oceans that boiled and skies of poison. After that came the Archean, when the world had cooled enough for the first oceans to settle and the first faint glimmers of life to take hold in them. Then the long, slow Proterozoic, the age of early life, when the world was filled, for unimaginable stretches, with little more than microbial mats and the patient work of single cells, who, over hundreds of millions of years, did something extraordinary. They slowly filled the air with oxygen, transforming the entire chemistry of the planet in an event so gradual and so total that it remade the world. That alone should tell us something. Life can change a planet beyond recognition, and it can do it so slowly that there is no single dramatic moment to point to. And then, only then, after some 4 billion years of this patient prelude, comes the chapter we ourselves belong to, the Phanerozoic, which means, roughly, the age of visible life. This is the chapter of fossils you can hold, of creatures you could recognize, of the great procession of life that fills museums and storybooks. And even this chapter, the one that feels like the whole of natural history to us, is only the last eighth or so of the Earth's entire existence. It began a little over 540 million years ago, with an event so sudden and so dramatic in the fossil record that we call it an explosion, the Cambrian explosion, when complex animals seem to burst into being across the ancient seas, trilobites scuttling on the seafloor, strange soft creatures with eyes and limbs and the first hard shells, the deep machinery of complex life switching on. From there, the procession quickens, the first fish, the first plants creeping onto bare and silent land, around 470 million years ago, turning the grey and rocky continents slowly green. The first animals following them out of the water, vast coal forests of giant ferns and towering club mosses, in an age when the air itself held more oxygen, and insects grew to sizes that would terrify us today, dragonflies with the wingspans of hawks. Then the great reptiles, and at last the dinosaurs, who would hold the world for 165 million years, an empire of life so long and so successful that it dwarfs our own brief moment almost beyond comparison. And after their sudden end, 66 million years ago, beneath a darkened sky choked with the dust of a fallen asteroid, the small surviving mammals crept out into an emptied world and began slowly to inherit it. Our own line, the line that would lead to us, branches off late in all of this. The earliest members of our own genus, the first creatures we would call human in any sense, appear only around 2.5 to 3 million years ago. Recognisably modern human beings, people like you and me, perhaps 300,000 years ago, farming and the first villages and the beginning of what we call civilization, only about 12,000 years ago. And our industrial age, as we keep returning to, only about 250 years. Lay all of that against the 4.5 billion years that came before, and the lesson presses itself upon you, gently but undeniably. There was an almost incomprehensible amount of time before we arrived. Hundreds of millions of years of complex life. Hundreds of millions of years of forests and oceans and changing climates and rising and falling worlds. All of it unfolding on a stage so deep and so old that our entire existence is the faintest scratch upon its final surface. And the Silurian Hypothesis simply asks us to look at all that depth, all that darkness behind us, and to admit, honestly, that we have only the dimmest idea of what it truly contains. So we have stretched the mind across deep time, and felt, a little, how vast it is. Now we come to the second great pillar of the question, and it is, in some ways, the most surprising one of all. Because when most of us imagine searching for a lost civilization, we picture archaeology. We picture explorers brushing dust from buried walls, lifting carved stones from the jungle, uncovering the bones of the long dead. We imagine that if something had truly existed, surely it would have left ruins, monuments, artifacts, something solid we could find and touch. But the deep, humbling truth that geologists understand, and that the rest of us rarely stop to consider, is that the Earth is not a faithful archive. It is, far more often, a great and patient destroyer. And almost nothing at all survives the deep passage of time. Start with fossils, the very things we rely on to know the ancient world existed. We tend to think of fossils as common, because museums are full of them, and the rock seems to hold them everywhere. But the reality is the exact opposite. Fossilization is one of the rarest fates that can befall a living thing. The overwhelming majority of all the creatures that have ever lived left no trace whatsoever. When an animal dies, in almost every case, it is eaten, or it rots, or it is broken apart and scattered, its bones weathering to dust, its body returning entirely to the cycle of life and decay, leaving nothing behind. For a fossil to form at all requires a rare and lucky set of conditions. The body must be buried quickly before scavengers and decay can do their work, usually in sediment, at the bottom of a lake or sea or in a flood of mud. It must then lie undisturbed for vast lengths of time while minerals slowly seep in and turn it, atom by atom, to stone. And then, after all that, the rock that holds it must somehow survive being crushed, melted, eroded, or dragged down into the depths of the earth, and must finally, by chance, be lifted back to the surface and exposed in exactly the right place at the right time for a human being to happen across it and recognise what it is. Every single fossil in every museum in the world represents a creature that won an extraordinary lottery, against odds so long they're almost beyond reckoning. Think of the dinosaurs again, who ruled the Earth for 165 million years, in numbers beyond counting, generation after generation, across the whole of the planet. From all of that, from that incomprehensible abundance of life across so vast a stretch of time, we have recovered only a relatively small number of reasonably complete skeletons. Entire species surely existed and lived their whole evolutionary story and vanished without leaving us a single bone. If even the dinosaurs, in all their numbers and their longevity, are so thinly represented, then what hope would there be of finding the delicate, fragile evidence of something far rarer, far briefer, and possibly far smaller in scale? And it gets harder still, because the surface of the Earth is not a stable, permanent thing that simply records the past and keeps it. The surface is constantly being remade. The great plates of the Earth's crust drift and collide and grind against one another over millions of years. Where they meet, the ocean floor is dragged down into the molten interior of the planet and destroyed, melted back into the deep, erased, completely. This is why the oldest rock on the floor of the oceans is only around 180 million years old. Everything older than that, every ancient seafloor, has been swallowed back into the earth and remade. The continents are tougher and older, but their surfaces are not. Wind and water and ice work upon them ceaselessly. Mountains rise and are worn entirely flat. Rivers carve canyons and then fill them again. Whole landscapes are buried beneath new sediment, or stripped away grain by grain and carried to the sea. The very ground we stand on is in constant, slow, restless motion, building up and tearing down again and again across the ages. The result of all this is something that should give us real pause. The amount of the Earth's land surface that actually preserves rock from any given ancient period, and that has it exposed where we could even study it, is astonishingly small. For a period tens of millions of years in the past, you might be looking at only a tiny fraction of the present land area, where rocks of that exact age are both preserved and visible at the surface. The rest is buried far too deep to reach, or has been destroyed entirely, or lies beneath the oceans, or beneath ice, or beneath the cities and farms of our own age. So even the best of our windows into the deep past are narrow cracks of light, scattered thinly across a planet that has, for the most part, simply thrown its old records away. Now bring our own civilization into this picture, and the lesson becomes vivid and a little eerie. Imagine our greatest cities. Imagine the towers of glass and steel, the vast tangle of roads, the airports, the dams, the endless sprawl of human building. It feels permanent. It feels like it could last forever. But run the clock forward, not 1,000 years, not 10,000, but 100 million. Nothing of it would remain standing. Steel rusts and crumbles within mere centuries if it is not tended. Concrete cracks and weathers and returns to sand and gravel. Glass shatters and grinds away. Wood rots in years. Within a few thousand years, even without anyone to knock them down, our cities would be ruins reclaimed by forest and sand. Within tens of thousands, barely a recognizable trace. And over millions of years, the relentless cycle of erosion and burial and tectonic destruction would grind the last of it down, scatter the fragments, and mix them so thoroughly into the rock that you would never assemble them back into the shape of a city. Let us make that vivid with a small thought experiment, the kind the scientists themselves enjoyed. Picture a single great city as it stands today, full of light and movement and steel. Now lift away the people and let the long ages roll. Within decades the power fails, the windows break, water seeps into every crack, and plants begin to push up through the streets. Within a century or two, the tallest towers, their steel skeletons rusting from within, begin to lean and fall. Within a few thousand years, the city is a low green mound, its shape softened beyond recognition, its metals corroded, its glass returned to sand. Within tens of thousands of years, a passing observer might not even know a city had ever stood there at all, and within a few million years the very ground itself will have moved on, the site buried under new sediment or stripped away by erosion, the last fragments crushed and scattered and mixed into the rock until nothing remains that could ever be reassembled into the idea of a city. Run that same process across 100 million years, and you understand why the scientists concluded that direct physical remains, the thing we instinctively search for, are almost the worst possible thing to look for. They are precisely the things that time destroys most completely. What lingers longest, strangely, are not the grand and obvious things, but the small and chemical ones. Not the tower, but the faint smear of unusual metals where the tower once stood. Not the machine, but the subtle shift in the chemistry of the sediment around it. The bigger and prouder a thing is, the faster the earth tends to erase it. The humbler and more diffuse a trace is, spread thin across the whole planet rather than concentrated in one proud monument, the better its chances of enduring, in some fragmentary and ambiguous form, into the deep future. It is a strange and humbling inversion of everything our instincts tell us. The pyramids, for all their staggering endurance by human standards, are nothing on the scale of deep time, but a thin global dusting of an unusual element, laid down everywhere at once, just might survive to puzzle a future geologist long after every wonder we ever built has vanished without a trace. What might survive, then, in some places, in tiny, scattered, unrecognizable scraps, are not buildings or bones at all, but something far humbler and far stranger. Perhaps a thin, dark smear in a layer of rock somewhere. Perhaps an unusual concentration of certain elements pressed into ancient sediment. Perhaps a faint and puzzling chemical signature. A wrongness in the numbers, a layer that does not behave the way the layers above and below it do. That is what a civilization becomes, given enough time. Not a city, not a statue, not a skeleton, a stain, a whisper in the chemistry of the rock, a thin and ambiguous line that a future geologist peering at a core drilled from deep beneath the seafloor might notice, and frown at, and wonder about, without ever being certain what it meant. And this is the point that Schmidt and Frank drove home, the realization that turns the whole question on its head. If we ourselves, after only 250 years of industrial activity, would leave behind nothing but a thin chemical layer, a few centimetres of strangeness in the rock, then we have been searching for the wrong thing. We have been imagining that a previous civilization, if it existed, would announce itself with ruins and relics and obvious wonders. But it would not. It could not. It would speak to us, if it spoke at all, in the faintest possible language, in trace elements and isotope ratios and the subtle signatures of a world that had been changed and then allowed, over millions of years, to heal. To find such a thing, we would have to know exactly what to look for, and we would have to look in exactly the right narrow window of preserved and exposed rock, and even then, even if we found something, we would face the agonizing problem of telling it apart from the many natural events that can leave similar marks. The fossilization problem, in the end, is not really about fossils at all. It is about the terrifying, humbling thinness of the record, and about how much of the past, perhaps almost all of it, is simply, quietly, and forever gone. So if a civilization does not leave behind cities or statues or bones, if all of that is ground to dust and scattered and lost, then what exactly would we look for? This is where the question stops being abstract and becomes, for a scientist, a real and answerable problem. Because Schmidt and Frank realised that to ask whether we could detect a past civilization, they first had to ask a very practical question about our own. What marks are we right now pressing into the rock that will one day be the deep past? What is the chemical signature of an industrial age? What, in other words, would our own thin, dark line in the rock actually be made of? And the answer turns out to be a list of subtle fingerprints, each one fascinating, and each one, frustratingly, ambiguous. The first and most important fingerprint is carbon. When we burn fossil fuels, coal and oil and gas, we are taking carbon that was locked away in the ground for hundreds of millions of years, the buried remains of ancient life, and we are releasing it, suddenly, into the air, as carbon dioxide. And here is the subtle and beautiful thing. Carbon comes in slightly different forms, called isotopes, that are almost identical but weigh a tiny bit different from one another. Living things, when they take in carbon, very slightly prefer the lighter form. So the carbon stored in the bodies of ancient plants and animals, the carbon that became coal and oil, is subtly enriched in that lighter isotope. When we burn all of it at once and pour it into the atmosphere, we shift the overall balance of carbon isotopes in the air and the oceans, tilting it toward the lighter form. This shift gets recorded in the rocks and the sediments and the shells that form during our age. Geologists call a change like this a carbon isotope excursion, and it is exactly the kind of fingerprint that could survive, in principle, for a very long time. A future scientist examining our layer might notice that the carbon isotopes had swung in a particular direction, and might recognise it as the trace of a vast and rapid release of ancient carbon. It is perhaps the clearest signature we're leaving. Alongside the carbon comes the warming itself, and the disruption of the oceans. A sudden flood of carbon dioxide warms the planet, and it also makes the seas more acidic, because some of that carbon dioxide dissolves into the water and changes its chemistry. This acidification dissolves the shells of tiny sea creatures and disrupts the entire ecosystem of the ocean, and it too leaves a mark in the sediments, a change in the kinds of creatures preserved, a dissolution of certain layers, a signature of a sea thrown out of its long balance. So warming and ocean acidification, together with the carbon shift, form a kind of linked set of fingerprints, a pattern that hangs together and tells a story of rapid, planet-wide change. Then there is nitrogen. One of the most transformative things our civilization ever did, though it rarely makes the history books, was to learn how to pull nitrogen out of the air and turn it into fertilizer on an industrial scale, to feed the crops that feed the billions of us. This process, this artificial fixing of nitrogen, has roughly doubled the amount of usable nitrogen flowing through the living systems of the planet. And that too changes the isotopic balance, this time of nitrogen, in the soils and the sediments and the runoff that washes into lakes and seas. A future geologist might find, in our layer, an unusual surge of nitrogen, a sign that something had massively disrupted the planet's natural nitrogen cycle, far beyond anything volcanoes or natural processes would easily explain. And then there are the things that are entirely new, the things that no natural process on Earth had ever produced before we made them. Plastics, for one. We have manufactured an almost unimaginable quantity of synthetic materials, and many of them break down with painful slowness, fragmenting into smaller and smaller pieces that work their way into soils and ocean floors all over the world. Some of these complex molecules might persist as faint chemical traces, strange organic compounds that nature does not make on its own. We have also scattered metals across the planet in ways nature never did. For much of the 20th century we added lead to gasoline, and as a result there is a global layer of lead pollution, detectable even in the ice of the most remote places on Earth, a thin, worldwide skin of a metal we spread through the simple act of driving. We have concentrated and dispersed rare metals, the special elements that go into our electronics, in patterns the Earth would never produce by itself. Perhaps the most haunting fingerprint of all is radioactive. In the middle of the 20th century, our species began testing nuclear weapons, and in doing so, we created and scattered into the environment certain artificial radioactive elements that had essentially never existed on Earth before, elements forged only in the heart of a nuclear explosion. We left a thin, distinct, globally distributed layer of these isotopes in the soils and sediments of the entire planet, laid down in just a few years in the 1950s and 60s. Some of these decay away quickly and would vanish long before deep time could preserve them. But certain of these artificial elements have very long lives indeed, long enough that, in principle, a faint trace might endure for tens of millions of years. Imagine that. A signature so unnatural, so impossible to produce by any ordinary geological process, that its mere presence in an ancient layer might be the single clearest possible sign that an intelligent species had once split the atom. It is a sobering thought that one of the most lasting marks we may ever leave on the Earth is the residue of our weapons. Put all of these together, and you have the chemical portrait of an industrial age. A swing in the carbon isotopes, a burst of warming and a souring of the seas, a flood of fixed nitrogen, strange synthetic molecules, dispersed metals, and the ghostly fingerprints of nuclear activity. This combined signature, this whole bundle of clues arriving together in a single thin layer, is what Schmidt and Frank argued we should be looking for, both in our search for life on other worlds and, more strangely, in the deep layers of our own. Because any one of these clues, found alone, could easily be the work of nature. But all of them together, arriving at once, in the same thin band of rock, would be far harder to explain by any natural cause. A constellation of signatures rather than a single star. And yet, even here, even with this whole list in hand, the honest scientist must add a sobering caution, and Schmidt and Frank were the first to add it. The trouble is that these fingerprints fade. The clearest of them, the carbon shift, is also the one that nature can produce all on its own, as we shall see. Plastics and complex molecules may break down beyond recognition over tens of millions of years. Even the most stubborn signatures grow faint and ambiguous with the deep passage of time, so we are left in a strange position. We can list, quite precisely, the marks an industrial civilization would leave, but we cannot be at all sure that those marks would still be legible after 100 million years, or that, if we found them, we could ever tell them apart from the great natural upheavals that the Earth has known. Which brings us gently to the most fascinating part of the whole story, the strange events that the rock record actually holds. Here is where the story takes a turn that genuinely surprised even the scientists who set out on it. Because when Schmidt and Frank went looking through the deep record of the Earth for events that might resemble the fingerprint of an industrial civilization, the swing in carbon, the sudden warming, the disruption of the seas, they did not come up empty. They found, scattered through the ancient layers, a number of strange, abrupt episodes when the planet's chemistry lurched, when carbon flooded the system, when the world warmed sharply and the oceans turned acidic, and when life was thrown into upheaval, all of it unfolding, geologically speaking, in the blink of an eye. These episodes are real, they are well documented, and the most famous of them looks, at first glance, unsettlingly like what you would expect if someone had once done to the Earth what we are doing to it now. The most studied of these strange events happened around 56 million years ago, in the warm world that followed the death of the dinosaurs. Geologists gave it a long and rather grand name, but you can think of it simply as the Great Ancient Warming. In the span of just a few thousand years, an eye blink in deep time, an enormous quantity of carbon was released into the atmosphere and the oceans. the planet warmed dramatically by something like 5 to 8 degrees Celsius across the whole globe. The deep oceans grew warm and acidic. Vast numbers of tiny-shelled creatures in the seas went extinct. On land, mammals shrank in body size and migrated across the warming continents, and the whole pattern of life shifted in response. And crucially, the carbon isotopes swung, exactly the kind of swing we just described, the signature of a sudden massive release of carbon into the system. If you only saw that fingerprint, the rapid warming, the acidified seas, the carbon excursion, you might, for a heart-stopping moment, wonder whether something had burned through the planet's buried carbon in a geological instant. Whether something, in other words, had behaved the way we behave. And this is precisely why Schmidt and Frank found this ancient warming so important and so instructive. Not because they thought a civilization had caused it. They did not, and neither does any other serious scientist. But because it is the closest natural analogue we have to the kind of event an industrial age would produce, and studying it carefully reveals both how similar and how different the two would be. Because when you look closely at this ancient event, you find a vital clue hidden in its timing. The natural warming unfolded over thousands of years, many thousands. The carbon was released, by whatever natural cause, slowly enough that it took millennia to build up. But our own release of carbon is happening over mere centuries, perhaps even faster. We're doing in 100 years what nature did in many thousands. And that difference in speed, that sharpness, is itself a fingerprint. A truly brief, intense industrial spike might appear in the rock as an even thinner, even sharper line than any natural event, a discontinuity so abrupt that nature would struggle to explain it. The very rapidity that makes our age dangerous might also be the thing that one day marks it as unnatural. The Great Ancient Warming was not the only such event. The Deep Record holds several others, smaller cousins, other sudden warmings, other carbon excursions scattered through the ages. There were strange episodes when the Earth's chemistry shifted hard and fast for reasons that scientists are still working to fully understand. There are layers in the rock where the world seems to have lurched in ways that took it a long time to recover from. The deep past, it turns out, is full of these abrupt events, these sudden lurches and recoveries, far more than the smooth and gradual story we sometimes imagine. The Earth has a long history of being disturbed, violently and quickly, and then, over hundreds of thousands of years, slowly healing. Now it is essential, absolutely essential, to be clear and honest about what all of this means, because this is exactly the place where careful science and wild speculation part ways, and where so many breathless stories go wrong. None of these ancient events are evidence of a prior civilization. Let me say that as plainly as I can in the quiet of this late hour. Scientists have good, well-supported, natural explanations for these events. The Great Ancient Warming was very likely driven by some combination of volcanic activity on a massive scale, the release of frozen deposits of carbon from the sea floor as the world warmed, and the slow rhythms of the Earth's orbit around the Sun, all working together to load the atmosphere with carbon. There is no need to invoke anything intelligent. There is no buried secret. The natural world on its own is fully capable of these great upheavals, and the evidence points clearly to natural causes. These are not unsolved mysteries hiding lizard cities. They are well-studied chapters of the Earth's own restless autobiography. So why do they matter so much to our question tonight? They matter because of what they teach us about the limits of detection. Here is the heart of it. If the Great Ancient Warming, a genuine natural event, can produce a fingerprint, a carbon swing, a sharp warming, an acidified sea that looks, in its broad strokes, like what an industrial age might produce, then the reverse is also true. It would be extraordinarily difficult, looking only at such a layer from 50 million years away, to tell for certain whether a given ancient carbon excursion was caused by volcanoes and melting seafloor ice, or by something that burned and built and thought. The natural and the artificial, viewed from the great distance of deep time, can blur into one another. The very fact that the Earth produces these events on its own means that a real industrial signature, if one existed in the deep past, could easily be mistaken for just another natural lurch, filed away under volcanism and orbital cycles, and never recognised for what it truly was. This is the genuinely unsettling realisation at the centre of the Silurian Hypothesis, and it is worth sitting with for a long, slow moment. It is not that we have found something strange and unexplained in the rocks. It is the opposite, in a way. It is that we have found that the rocks are full of sudden, dramatic, natural events that resemble the signature we would expect from a civilization, and that we therefore have no reliable way of telling the two apart across such immense spans of time. A previous industrial age, should one have existed, would not appear in the record as an obvious miracle. It would appear, if it appeared at all, as just another ambiguous carbon excursion, just another strange warm spell, indistinguishable from the natural pulse of the planet. Hidden not because it left no trace, but because the trace it left looks too much like everything else. To pull a real civilization out of that ambiguity, scientists agree you would need more than a single fingerprint. You would need that whole constellation we spoke of earlier, the carbon swing and the artificial elements and the strange molecules and the radioactive signatures, all arriving together, all in one impossibly thin layer, in a combination that nature simply could not produce by itself. A single carbon excursion proves nothing, but a carbon excursion stacked together with traces of plutonium and synthetic compounds, and a doubling of fixed nitrogen, all in the same instant of deep time, that would be a different matter entirely. That would be something no volcano could fake, and so the search, if there ever truly is one, is not for a single anomaly. It is for a fingerprint too complex, too specific, too unnatural, to be anything but the work of a mind. So far, in all the layers we have read, we have found no such thing. The record, as best we can read it, is consistent with us being the first. But the honest scientist adds in a low voice that the record is also thin and patchy and easily misread, and that the deep past keeps the great majority of its secrets entirely to itself. And so we come to the most speculative part of our journey tonight, the part where we let the imagination wander furthest, while keeping, always, one careful hand on the rail of what is actually known. If we cannot rule out with perfect certainty that something came before us, then it is natural to wonder. Who could it have been? Across all those hundreds of millions of years of complex life, were there any creatures who might, even in principle, have walked the long road toward intelligence and technology? Let me be absolutely clear before we begin, so that nothing tonight is misunderstood. There is no evidence, none at all, that any species before us ever built a civilization. Every line of inquiry we have, from the genetics of living things to the bones in the ground to the chemistry of the rocks, is fully consistent with human beings being the first and only technological species this planet has ever produced. What follows is not a claim. It is a thought experiment, a gentle wondering, an exploration of what was even possible, told in the spirit of curiosity rather than belief. The most obvious candidates, if we are honest, are the dinosaurs, and not because of any evidence that they were intelligent in our sense, but simply because of how long they had. The dinosaurs ruled the Earth for around 165 million years. Pause on that number, because it is almost impossible to take in. Our own genus has existed for less than 3 million years, modern humans for 300,000. The dinosaurs held the world for more than 500 times longer than modern humans have even existed. Across that vast stretch, they evolved into a staggering variety of forms, and some of them, particularly among the smaller, sharp-eyed predators, developed relatively large brains, keen senses, grasping hands, and what may have been complex social behaviour. They were not the lumbering, slow-witted creatures of old cartoons. Some were quick, agile, and by the standards of their kind, clever. There was one scientist, decades ago, a paleontologist studying one of these brainy little predators, who carried this thought to its logical and rather eerie conclusion. He noticed that this particular dinosaur had an unusually large brain for its body, forward-facing eyes that gave it depth perception, and slender hands that could grasp. And he wondered, purely as a thought experiment, what such a creature might have become if its line had not been cut short, if it had continued evolving along the path that brains and hands and binocular vision seemed to favour. He even built a model of what he imagined such a being might look like, tens of millions of years down that road, a tall, upright, large-headed creature, and he called it simply the Dinosauroid. It was always meant as speculation, and it was sharply criticised by other scientists, who pointed out that it imagined the dinosaur evolving suspiciously toward a human shape, as if intelligence had only one possible body. But the underlying point lingered. The dinosaurs had the time, and at least some of them had the raw ingredients. Whether they ever could have built anything, we will simply never know, because their road was cut short 66 million years ago by a falling stone from the sky. But intelligence on Earth has taken other forms too, and some of them are alive today, which makes them far more than mere speculation. Consider the octopus and its cousins, the cuttlefish and the squid. These are creatures whose intelligence is genuine, measurable, and deeply strange to us, because it evolved along a completely separate path from our own in the alien world of the sea. An octopus can solve puzzles, open jars, use tools, recognize individual human faces, and escape from sealed enclosures with what looks unmistakably like cunning. It has a large and complex nervous system, much of it distributed through its arms, so that in a sense it thinks with its whole body. If you wanted proof that high intelligence can arise more than once, and in radically different forms, the octopus is that proof, swimming in our oceans right now. And yet, for all its brilliance, the octopus shows us something else too. It shows us how many other ingredients a civilization requires beyond raw cleverness alone. Because building a technological civilization, it turns out, is not just a matter of being smart. It demands a very particular and unlikely combination of gifts, all present in the same creature at the same time. You need intelligence, yes, but you also need hands or something like them, manipulative limbs capable of fine and delicate work, of shaping tools and materials. The octopus has wonderfully dexterous arms, but it lives in the water, and that points to perhaps the single greatest obstacle of all. Fire. Almost every step on the human road to technology depended directly or indirectly on fire. Cooking food which fueled our hungry brains, hardening tools, smelting metals, firing clay, eventually driving engines, and fire simply cannot burn underwater. A brilliant ocean civilization, however clever, would be locked out of metallurgy, locked out of chemistry, locked out of nearly the entire path that led us to where we are. Whatever the octopus might dream, the sea itself forbids it the tools. And there is more still. You need long lifespans, or at least long enough to learn and to teach. You need a way to pass knowledge from one generation to the next, so that learning accumulates instead of dying with each individual. The octopus, for all its genius, lives only a few short years and in most species dies soon after reproducing, often never even meeting its own offspring. Each octopus must learn the world fresh. alone, and takes its hard-won wisdom with it to the grave. There is no library, no teaching, no accumulation. And without accumulation, without the slow piling up of knowledge across the generations, you cannot build a civilization no matter how clever any single mind may be. You need society. You need cooperation on a large scale. You need language, or something that does the work of language. The astonishing truth is that intelligence by itself is almost certainly common in the long history of life. But the full, rare, improbable bundle, intelligence and hands and fire and long life and teaching and society and language, all together in one lineage at one time, may be staggeringly rare. Perhaps it has only happened once with us in 4.5 billion years, which casts the whole question in a softer and more philosophical light. The Silurian Hypothesis does not really ask us to believe that the dinosaurs had cities, or that some forgotten creature smelted iron 100 million years ago. It asks us instead to confront two truths at once, and to hold them together. The first is that we cannot completely prove we were the first, because the record is too thin to be certain. And the second is that, even so, all the evidence and all the reasoning we have suggests that we very probably were the first, because the path to technology is so narrow, so demanding, so improbable, that it may almost never be walked at all. We are left, then, not with a likely lost civilization, but with a profound appreciation of just how unlikely our own existence is. How many things had to align? How many gifts had to gather in one creature, at one moment, on one small world, against the vast and patient backdrop of deep time? We may well be the first, and if we are, that is not a small or ordinary fact. It is perhaps the most extraordinary thing about us. There is a deeper current running beneath this whole question, and it carries us out now, from the rocks of our own planet to the silence of the wider universe. Because the Silurian Hypothesis, though it began as a question about Earth's past, is really a cousin of a much larger and older puzzle, one that has troubled thinkers for generations. It is sometimes told as a simple story. A great physicist sitting at lunch with colleagues, talking idly about the possibility of life among the stars, is said to have suddenly asked a deceptively simple question. If the universe is so vast and so old, and if life and intelligence are anything but rare, then where is everybody? Why, when we look up at the immense and ancient sky, do we see only silence? The galaxy is more than 10 billion years old. It holds hundreds of billions of stars, and we now know that planets are common around them, countless worlds. There has been time, almost unimaginable time, for civilizations to arise, to spread, to fill the heavens with their signals and their works. And yet, when we listen, we hear nothing. When we look, we see no one. The sky is quiet. This is the great puzzle, the strange and resounding silence of a universe that ought, by all rights, to be crowded with voices. There are many possible answers to that silence, and one of them connects directly to everything we have been talking about tonight. It is an idea sometimes called the Great Filter. The reasoning goes like this. The road from lifeless matter to a galaxy-spanning civilization is long, and it passes through many stages. The first stirrings of life from chemistry, the leap from simple cells to complex ones, the emergence of intelligence, the development of technology, the survival of that technology long enough to reach the stars. Somewhere along that road, the reasoning suggests there must be a step so difficult, so improbable, that almost nothing ever gets past it. A filter, a bottleneck through which almost no one passes. And the haunting question is, where does that filter lie? Is it behind us, in some early step we were lucky enough to clear, meaning that we are rare survivors and the road ahead is open? Or is it ahead of us, lying in wait, a wall that civilizations reach and do not pass, a trap that has silenced everyone who came before, and that we are now approaching in our turn. This is where the Silurian Hypothesis and the silence of the stars reach out and touch one another, and where the whole question becomes suddenly very personal. Because one possible explanation for the silence is simply that industrial civilizations do not last, that they are, by their very nature, brief, that a species, upon discovering how to burn the buried energy of its world and to reshape its planet, sets in motion changes to its climate, to its resources, to its environment, that it cannot easily control, and that more often than not bring its own brilliant age to a close before it can ever reach the stars or leave a lasting mark. If that is true, if civilizations tend to flare up and fade out in a geological eye blink, then two things follow, and they fit together with an almost frightening neatness. The first is that the galaxy could be littered with the faint, fading traces of civilizations that rose and fell long ago, too brief and too distant for us ever to detect, just as a past civilization on Earth would be too brief and too buried for us to find. And the second is that the silence we hear when we look at the stars might not be the silence of an empty universe. It might be the silence of a universe full of thin, ancient, forgotten layers, full of the chemical ghosts of the once living, scattered across worlds we will never visit, each one a story that ended before anyone was there to hear it. And here is the part that should make us sit up, even as we drift towards sleep. We are right now writing exactly such a layer ourselves. This is not a thought about the distant past or some other world. It is happening beneath our own feet, in our own age as we speak. Every ton of carbon we release, every shift we cause in the chemistry of the air and the seas, every artificial element we scatter, every layer of plastic and metal and altered soil we lay down is, in the language of deep time, the writing of our own signature into the rock. Tens of millions of years from now, whatever comes after us, if anything does, might drill down through the layers of the earth and reach a thin, dark band, a sharp swing in the carbon, a strange burst of nitrogen, a faint and unnatural trace of metals and synthetic things, and they might pause and frown and wonder what once happened here. We are not only the ones asking the Silurian question, we are, in a very real sense, becoming the answer to it. We are the prior civilization for whoever might come next. That thought can be frightening, and there is no use pretending otherwise. But it can also be clarifying even, in a strange way, calming if we hold it gently. The scientists who first asked this question, and especially the astrophysicist among them, went on to think hard about what it means for us. And the conclusion they reached was not one of despair, but of a sober and grown-up kind of hope. The point of realizing that industrial civilizations might be fragile, that they might tend to flare and fade, is not to surrender to that fate. It is to recognize it clearly enough to choose a different one. A civilization, they argued, is not separate from its planet. It is part of it, woven into its cycles of carbon and water and life. And a young civilization, in its first centuries of power, faces a kind of test, a coming of age. It has learned to draw enormous energy from its world and to change that world on a planetary scale, but it has not yet learned to do so wisely, to live within the limits of the system that sustains it. The question of survival is the question of whether it can grow up in time, whether it can learn to be a lasting part of its planet rather than a brief and destructive fever upon it. We have in fact small and gentle rehearsals of this idea within our own short human story, though we must hold the comparison lightly, for they are nothing like the planetary scale we're imagining. Across the few thousand years of recorded history, civilizations have risen, flourished, and faded again and again. Great cities that once held countless lives now lie quiet beneath jungle and sand, their names half forgotten, their languages unread for centuries until some scholar painstakingly recovered them. Whole peoples who built and farmed and traded and dreamed, left behind only scattered ruins and a silence we are still trying to fill. And in many of these cases the cause was not war or conquest at all, but something slower and sadder, a changing climate, an exhausted soil, a drying river, a way of life that outgrew the land that fed it. These were not stupid people. They were as clever and as capable as we are. But cleverness didn't save them, because the challenge they faced was not a challenge of cleverness. It was a challenge of living within limits, of reading the slow warnings of their environment, of changing course before the change was forced upon them. Their stories, recovered now from the dust, are tiny mirrors held up to our own much larger moment, and they whisper the same patient lesson, the deep time of the rock whispers, that endurance is not given, it is earned again and again by wisdom. Now lift that lesson from the scale of a single city to the scale of an entire planet, and from a span of centuries to a span of millions of years, and you arrive at the sober heart of the great filter as it touches us. The danger a young industrial civilization faces is not that it is foolish, but that it is powerful before it is wise. It learns to draw upon the deep energy of its world, the buried sunlight of ages, faster than it learns the consequences of doing so. It reshapes the chemistry of its own air and seas in a few short centuries, far faster than the slow natural rhythms that the planet's life evolved to handle. And whether it survives that reckless, exhilarating, dangerous adolescence depends entirely on whether it can grow up in time, whether it can learn to match its wisdom to its power before the bill comes due. That is the test. It is the same test the lost cities faced, only vast beyond imagining, and we are taking it now in our own time, whether we wish to or not. They are also a kind of message, written in the deep grammar of time itself. They tell us that brilliance is not enough. That cleverness by itself does not guarantee endurance, that the universe doesn't owe any civilization a future simply because it learned to build and to burn. And they remind us, with the quiet authority of 4.5 billion years, that the difference between leaving a thin and forgotten stain in the rock and leaving something more, something lasting, is not a matter of intelligence at all. It is a matter of wisdom, of restraint, of learning in time to tend the only world we have. We do not know whether the great filter lies behind us or ahead. We do not know whether we'll pass through the narrow gate or be stopped at it like, perhaps, so many others. But we do know now that the test is real, and that we are taking it, and that the answer for once is not buried in the deep past or hidden among the stars. The answer is ours to write, in whatever layer we choose to leave behind. Now, you might be wondering, after all of this, what scientists actually do with a question like the Silurian Hypothesis? Because it can sound, at first, like a riddle with no use, a puzzle that leads only to a shrug and an admission that we cannot know. But that is not how good science treats a hard question. A question that cannot be fully answered is not useless. Often, it is the most valuable kind of all, because it reshapes how we look at everything around it. And this question, it turns out, has quietly changed the way researchers think about several very real and very active fields, even though no one is out there literally digging for the cities of the lizard people. Let us spend a little while gently on what this strange idea has actually given us. The first and most important gift is to the search for life beyond the Earth. This was, after all, where the whole question began, in a conversation about detecting civilizations on distant worlds. For a long time, the search for life elsewhere focused on what we call biosignatures, the chemical traces that living things, in general, leave on their planets. Oxygen in an atmosphere, for instance, or certain other gases that life tends to produce. But the Silurian hypothesis pushed scientists to think more carefully about a different and harder target, what we might call technosignatures, the specific traces left not by life in general, but by technological industrial civilization in particular. By working out, in detail, what fingerprints our own industry presses into our own world, the carbon shift, the strange nitrogen, the artificial elements, the pollutants that nature does not make, researchers built a kind of checklist of what to look for on other planets. When we point our great telescopes at distant worlds and analyse the light filtering through their atmospheres, we now have a clearer sense of what an industrial world's air might reveal, what unnatural combinations of gases might betray the presence of a technological species. The Silurian Hypothesis, in other words, taught us how to recognise a civilization by its chemistry, and that lesson reaches all the way out to the stars. The second gift is closer to home, and it touches the study of our own present age. In recent years, scientists have been seriously debating whether to formally recognise a new chapter in the Earth's geological history, a chapter defined not by natural forces but by us, by human activity, by the profound and planet-wide changes our civilization has caused. Whether or not it ever becomes an official entry in the great calendar of the rock, the very effort to define it has forced researchers to ask, with real precision, what our lasting mark on the planet actually is. Where exactly in the layers forming today does our signature begin? Which fingerprint is clearest and most enduring? Many scientists point to the thin global layer of artificial radioactive material laid down by nuclear testing in the middle of the 20th century as the sharpest, most unmistakable line, a marker so unnatural and so precisely dated that it stands out clearly from everything before it. In studying our own emerging layer, in arguing about how to read it, scientists are in effect practicing the exact skill the Silurian hypothesis demands. They are learning to read the signature of a civilization in the rock, using the only example we have, ourselves. And this points to the practical heart of any real search, should one ever be undertaken. We would not be looking for buildings or bones. We would be looking deep into the layered archives of the planet, the long cores of sediment drilled from the floors of the oceans, the ancient layers exposed in cliffs and quarries, the records locked in the deep ice of the poles. These are the closest things the Earth has to pages, laid down year by year, age by age, each thin band a record of the conditions when it formed. And what we would look for, what would actually count as discovery, is not any single strange thing, but a particular and impossible combination, all arriving together in one impossibly thin layer. A sharp swing in the carbon, yes, but together with a surge of fixed nitrogen, together with traces of metals concentrated in patterns nature does not produce, together with complex synthetic molecules, together, perhaps, with the faint signature of artificial radioactive elements. Any one of these alone could be the work of a volcano or an ocean, or the slow chemistry of the planet. But all of them at once, in the same razor-thin band of rock, would be a fingerprint that nature simply cannot forge. That is the target. Not a ruin, but a coincidence too perfect to be natural. Here we must say something honest and important about how science treats this whole pursuit, because it reveals the quiet integrity at the heart of the discipline. So far, in every layer we've examined, in all the cores and cliffs and ice we have studied, we have found no such combination, no fingerprint that requires a prior civilization to explain it. And that absence is itself a result. It is meaningful. Every layer we read and find to be natural is another piece of evidence, gentle but real, supporting the conclusion that we are in fact the first. A negative result is not a failure. In science, finding nothing, when you have looked carefully and known exactly what to look for, is finding something, It is finding that the thing is not there, or at least not where you looked, and that quiet accumulation of nothing is part of how we come to be reasonably confident, though never absolutely certain, that human beings are the first technological species this world has known. Looking ahead, the tools for this kind of reading only grow sharper. Our ability to measure the isotopes of carbon and nitrogen and other elements grows more precise with each passing year, letting us detect fainter and fainter shifts in older and older layers. We are developing new ways to sift through enormous quantities of geological data, to comb the rock record for patterns that a human eye might miss, anomalies that stand out from the natural background. And the question reaches beyond the Earth entirely. The same reasoning applies to our neighbour, Mars, a world that was once warmer and wetter than it is today, with rivers and lakes and perhaps the conditions for life, before it dried and froze into the cold red desert we see now. If we are ever to read the deep history of Mars, the Silurian way of thinking tells us how to do it, and what the limits of our reading will be. It reminds us that even there, even on another world, the absence of obvious ruins would prove very little, and that the real evidence, if any exists, would be subtle, chemical, and hard-won. But perhaps the most important implication of all is not a method or a measurement. It is a stance, a habit of mind, a kind of intellectual humility that the Silurian Hypothesis quietly insists upon. It teaches us to be careful about the difference between what is true and what we are merely able to detect. It teaches us that the confidence we feel about being first rests not on the rock having told us so, but on the rock having stayed silent when we asked, and on our reasoning about how unlikely a rival would be. It teaches scientists to hold their conclusions with an open hand, to remember always how thin the record is, how much has been lost, how easily the past hides itself, and that humility, that willingness to say we are very probably first, but we cannot be entirely certain, and here precisely is why, is not a weakness in the science. It is its greatest strength. It is the difference between a story we tell ourselves to feel important and a truth we have honestly tested against the silence of the deep. The Silurian Hypothesis, in the end, may never find a lost civilization. It was never really meant to. What it found instead was a clearer, humbler, and more honest way of looking at the past, the present, and the long, dark reaches of time that surround us on every side. And now, as the hour grows later and the world outside grows quieter, let us set the science gently to one side and simply sit for a while with what all of this means. Because beneath the isotopes and the rock layers and the careful reasoning, the Silurian Hypothesis touches something that is not really a scientific question at all. It touches the oldest human feelings of all, the feeling of being small beneath a vast sky, the feeling of wondering whether we matter, and to whom, and for how long, the feeling of standing at the edge of an immensity that does not know our name. These are not problems to be solved. They are mysteries to be felt slowly in the quiet, the way you feel the cool of the night air or the weight of your own tiredness settling over you now. Think, first, of the sheer humility of our place in time. We spoke earlier of compressing the whole history of the Earth into a single year, and of how all of human existence amounts to the last breath before midnight on the final day. That is not a fact to be frightened by. It is in its way a fact to be moved by. Everything you have ever known, everyone you have ever loved, every story ever told, every kingdom that ever rose, every discovery, every triumph, every sorrow, all of it belongs to that final shimmering instant. We're a very new thing in a very old world, and there's a strange tenderness in that, a softness when you really let it settle. We are not the long, slow story of this planet. We are its sudden, bright, fleeting present, awake for a moment in the middle of an enormous and patient dark. And consider what it means, this idea that time itself is the great eraser. We so often think of the past as something solid, something that simply is, waiting to be remembered. But the Earth teaches us otherwise. The Earth forgets. It forgets almost everything. It grinds the mountains flat and swallows the seafloors whole, and scatters the bones of the mighty into dust too fine to gather. The overwhelming majority of all that has ever lived, all that has ever happened on this world is gone now, gone utterly, beyond any recovery, leaving not even a whisper. And one day, in the slow turning of the ages, almost everything we have made will go the same way. Our cities, our monuments, our names will thin and fade and finally vanish into the rock, until perhaps only a faint chemical shadow remains, a stain that something someday might puzzle over without ever knowing it was us. There is a melancholy in that, of course, but there is also, if you turn it gently in the light, a strange and liberating peace. Because if time erases nearly everything, then the worth of a thing was never in how long it lasted. A sunset is no less beautiful for being brief. A life is no less precious for being short. The flower that blooms for a single day is not a failure. It is simply wholly itself for the time that it has. There is something else too, something quieter and harder to name, in the possibility that we might be the first. If it is true, if in 4.5 billion years no mind ever rose on this earth before our own, then we carry a peculiar and lonely distinction. We are the planet's first attempt at self-awareness, the first eyes through which the Earth has ever looked back at itself and asked what it is. For 4 billion years the seas rolled and the continents drifted and the great forests grew and fell, and there was no one to see it, no one to name it, no one to wonder. And then, in the last shimmering instant, we appeared, and for the first time the universe had, on this small world, a witness. That is a heavy and beautiful thing to carry, to be perhaps the first to know that we are here at all, to be the part of the cosmos that woke up and looked around and felt the strangeness of existing. Whether or not anyone came before us, we are, right now, the ones who are awake. And being awake, being able to ask the question at all, is itself a kind of miracle that the long dark ages before us never knew. And what of the legacy we're writing now, in our own thin layer? There is a way to feel this that is full of guilt and dread, and that feeling is not entirely without reason. But there is another way to feel it too that is gentler and perhaps truer in the long run. We are, whether we chose it or not, leaving a mark on the deep future. We are writing a line in the rock that may outlast every word we have ever spoken. And the question the Silurian Hypothesis poses to us in the end is not really whether someone came before. It is what we would want a future reader to find if they ever found us. Would we want our layer to read as the trace of a brief and reckless fever, a species that burned bright and burned out, that changed its world without understanding it and was gone? Or would we want it to read as the beginning of something that learned, in time, to last, that grew up, that became a steady and tending part of its planet rather than a passing storm upon it? We cannot know who, if anyone, will ever read our layer, but we can choose now what it will say, and there is a deep dignity in that choice, a quiet responsibility that belongs to us alone, the first and so far the only ones awake. Perhaps the most consoling thought of all is this: the universe does not keep records the way we wish it would. It does not hold a great book in which every life and every deed is written down forever. The rock forgets. The stars are silent. Time washes nearly everything away. And so meaning, if there is to be any meaning at all, is not something we find written in the world waiting for us. It is something we make, here, now, in the brief warm interval of our being awake. The Silurian Hypothesis, for all its cold deep time and its talk of erased civilizations, leads us strangely back to a very simple and very human truth, that the moment we have is the moment that matters, that the people beside us, the world around us, the quiet of this very night, are not less precious because they are fleeting. They are more precious precisely because they are. We do not need the rock to remember us in order for our lives to have weight. We need only to live them, fully, gently, while we are here, in the small lit circle of the present, surrounded on every side by the vast and patient dark. So let the immensity of time be, tonight, not a weight pressing down on you, but a kind of vast and quiet blanket spread out beneath the stars. You're a small, warm, waking thing in the middle of an ancient and sleeping world. And there is nothing frightening in that. There is only rest. And so we come slowly and softly to the end of our journey tonight, though endings, as we've learned, are strange things in the language of deep time. We began with a single unsettling question, asked not in fear but in honesty. Are we truly the first? And we have followed that question all the way down, through the unimaginable depths of the Earth's history, through the thin and forgetful record of the rock, through the faint chemical fingerprints of a civilization, and the strange natural events that mimic them, through the narrow, improbable road that leads to a thinking, building mind, and out, at last, into the great silence of the stars and back again to the quiet of our own present moment. And what have we found at the bottom of all that depth? Not a lost civilization, not the ruins of the ones who came before. We have found, instead, something gentler and stranger. We have found the honest measure of how little we can know, and how much that little is worth. Let the whole of it settle over you now, not as facts to be remembered, but as a feeling to drift upon. Feel the age of the world beneath you, 4.5 billion years of patient turning, the seas that rolled before there was anyone to name them, the forests that grew and fell in silence, the long, slow breathing of a planet that does not need us, and was here for an eternity before us, and will be here, in some form, long after we are gone. Feel how thin and bright our own moment is, balanced on the very surface of all that depth, the last shimmering instant of an enormous year. And feel, too, that there is nothing to fear in any of it. The vastness is not a threat. The deep time is not a darkness that swallows. It is more like a great still ocean on which your small warm life is floating, held up gently by everything that came before. We do not know whether anyone walked this earth before us and rose to greatness and fell and was forgotten. The honest answer, the scientific answer, is that we very probably are the first, and that the road to becoming what we are is so narrow and so improbable that perhaps no one ever walked it here before. But we cannot be entirely certain, and the reason we cannot be certain is itself the most beautiful lesson of all. It is that the earth forgets, that time erases, that almost nothing lasts. And that, far from being a sad truth, is the very thing that makes this present moment, your present moment, lying here in the quiet, so impossibly precious. You're awake now in the one instant that is yours. The rock will not remember it, the stars will not record it, but it is happening, and it is real, and it is enough. If there is anything to carry from tonight, as you drift down towards sleep, let it be only this, that we are a young and waking thing in an old and sleeping world, that we are perhaps the first eyes through which this planet has ever looked upon itself, and that the layer we're writing now, the faint mark we will one day leave in the deep, is still being written, still ours to shape, still unfinished. We do not have to be a brief and reckless fever, We can choose, if we are wise enough and gentle enough, to be the beginning of something that learns to last. That choice is not made in some distant future. It is made in the way we live and tend and care in the small lit circle of our brief warm now. But that is a thought for the waking hours, and the waking hours are not now. Now is for rest. Now is for letting the great depth of time become a blanket and not a burden. Imagine yourself sinking slowly and safely down through the soft layers of the Earth's long memory, past the cities that will one day be dust, past the bones that will one day be stone, past the forests and the seas of ages we will never see, down and down into the warm, dark quiet at the heart of all that time, where there is nothing to solve and nothing to fear, only the slow and patient turning of a very old world, holding you as it has always held everything gently in the dark. The question that began our night, whether we are the first, no longer needs an answer. It has done its quiet work. It has carried us out to the edge of the unknowable and brought us safely back, a little smaller, a little more humble, and a little more at peace. Let it go now. Let the isotopes and the deep layers and the silent stars dissolve into the soft blur of sleep. There is nothing more you need to think about tonight. The Earth is very old, and you're very tired, and both of those things are exactly as they should be. Thank you truly for spending this slow stretch of the night here with me. If you found some rest in it, that is all I ever hope for. Breathe slowly. Let your thoughts grow quiet and far away, like distant layers settling in the deep, and let the long, patient, forgiving silence of deep time carry you gently down into sleep. Good night. Sleep well, and rest easy, here, in your own small bright moment, in the middle of the vast and quiet dark.